Hello students, it is the third day of first lesson gravitation from science section A. Before this one, we have discussed Kepler's law and the Newton's law of gravitation, and while explaining or while understanding the Newton's law, we have discussed force in between two objects is directly proportional to product of the masses, that is F is directly proportional to m1 m2, and secondly we have discussed the force is inversely proportional to square of the distance, that is force inversely proportional to d square. That also we have discussed. But now we are discussing how Newton assumed the force in between two objects is inversely proportional to square of the distance between them, and to prove that Kepler's third law helped him and how Kepler's law helped him, that is the point today we are discussing. So see, what is the question I have written? How Newton was helped by Kepler? Kepler's third law to assume inverse square dependence of the distance in his law of gravity. See, what is Kepler's third law? Kepler's third law is square of a time period of revolution of a planet around the sun is directly proportional to cube of distance between the planet and the sun. That is the third law. And by this proportion, we come to conclusion t square divided by r cube is equal to k, that is constant. If we do invert into here, so r cube divided by t square ulta, that is equal to 1 upon k. As k is constant, 1 upon k is also constant. No problem for this one, and that is equation number 1. So by Kepler's third law, we have reached the final conclusion here. Wherever we are going to find r cube divided by t square, that we are going to consider that as a constant. How explain how Newton's law can be discussed? See, first, force in between two objects is directly proportional to m1 m2, that is product of masses between two objects, and inversely proportional to, that is force is directly proportional to 1 upon r cube, or inversely proportional to only r square. R cube not, r square. Now see how we are going to join this all. And to understand this, how Kepler's third law helped Newton to assume that inverse square dependence, for that one, once again we are going to discuss circular motion. See, the object, this is an object of mass m. So mass of object is m, and it is moving in a linear path with velocity v. Uniform linear motion is there, and at the same time, if we are going to hold or pull that object downward perpendicular, normally perpendicular down, then definitely the change in the motional direction is going to happen, and the object starts to move along the circular path. So what is circular motion? Circular motion is a motion of an object along the circular path. And so for that we need the force towards the center. So center seeking force is called a centripetal force, and this centripetal force can be given by, if object's mass is m, velocity is v, and radius of the circular path is r, then centripetal force is equal to mv square divided by r. So wherever we are going to discuss centripetal force, then we should consider that is mv square divided by r. But see now, this object is not an ordinary object, now it is a planet. So what is m? Mass of a planet is m. Instead of object, we are considering here now the planet. And the planet's velocity is v. Here at the center we having here location of sun. So the circular orbit's radius, that means the distance in between sun and the planet, is r. So what is true with the object, that will be true with the planet. So when object was there, the force towards the center is F, that is mv square divided by r. So that is true with the planet. So gravitational force on this planet towards the sun, that is also F, and that can be given as mv square divided by r. M means mass of a planet, v velocity of a planet, r is the distance in between sun and the planet. But again we have to know that equation of force, that is speed is equal to distance traveled divided by time. But when the object is moving along a circular path, it will cover the distance is equal to its circumference. So circumference is 2 pi r. So distance traveled is 2 pi r. And consider t is a time period taken by the planet to complete the one rotation along the one revolution around the sun, and so that will be considered as a t. So what is t? T is a period of revolution of a planet taken by the planet to complete a one revolution around the sun. So finally we are reaching speed, that is velocity, when the circular speed is equal to 2 pi r divided by t. See, we are having here f is equal to mv square divided by r, and the value of v we having here. So shall we fill the value from equation number 3 in equation number 2? We are reaching to the final point here. See, from equation 2 and 3. Equation 2, f is equal to mv square, v value we having here. So see here, v square means 2 pi r upon t whole square. So m is as it is 2 square 4, pi square, r square, and numerator directly reaches to the denominator. So t square we have written here. So finally we are getting m into 4 into pi square into r square, and for denominator t square divided into r. So see, squares and this r get cancelled. So finally we are reaching 4 m pi square, only 1 r and t square. So out of this we have written this one as a separate. See, and here we having r divided by t square, but there r cube divided by t square is equal to constant. So to do r cube we have to multiply by r square. So here for this numerator and denominator we have multiplied by r square. So r into r square, r cube, and t square into r square, t square, r square. So see, finally we have reached r cube divided by t square. So we have written this one as a separately. So what is constant? 4 is constant, not change. Mass of a planet will not change. Will it change? See, Earth is moving around the sun and mass is changing at every instant. It is not possible. So mass of object is considered, or planet is considered a constant. 4 is a numerical, that is constant. Mass of Earth or any planet, that is also constant. Pi, it is already constant. So 4m pi square, 4m pi square, this is already constant. Then r cube divided by t square, that is 1 upon k, that is also constant. So this all figure is a constant, and so we have written here 1 upon k into 1 upon r square. So see, within last video I have explained, to convert proportionality into equality we have to consider one constant. If I want to remove this constant, then equal to will convert into proportionality. So see here, f as it is 1 upon r square we have written as it is, and if you are going to remove this constant, this equal to will convert into proportional. So finally we have reached force of gravity in between the sun and the object is proportional to 1 upon r square, that is inversely proportional to r square, that is inversely proportional to square of the distance in between two objects or a sun and the planet. In this way, by using this part, see, by using this much part. So what is this? This is Kepler's third law. Actually t square divided r cube, but here we have taken as a inverted window. By using this Kepler's third rule, we reach the final f is inversely proportional to r square. In this way, Kepler's third law helped Newton to explain to assume inverse square dependence on the distance in his law. See here, some interesting information we are going to discuss it now. There are two bodies. Two bodies means what? Any object or a person. Because Newton explained this law as a universal law, that means it will be applicable for all the objects from the universe, all the people, person from the universe, animals too. See, first we are discussing one example. There are two people. First name is as Ram and second is Rahim. They are standing. See where they are standing, we will discuss it later, because if they are standing on the earth, definitely earth will pull them down. And so we are discussing they are in the space. Any other forces are not acting on Ram and Rahim, them only. See, Ram's weight, that means mass of Ram is 100 kg. At the same time, for better example, we are discussing Rahim's weight also 100 kg. So two objects, don't focus Ram and Rahim, there are two objects. Consider as a person. They are of same weight, that is mass is same, and they are standing 1 meter away from each other. That means, see, shape is irregular. So as we have discussed earlier, center of mass is very important, and the distance in between center of mass of Ram and Rahim is 1 meter. Like this we should discuss. Then what is the force? Definitely these are the two objects get attracted by each other according to Newton's law of gravity. So how to find this one? See, force is equal to axle, that is gravitational constant, into mass of first object into mass of second object, divided by d square. So what is the value of G? G's value is 6.673, but here we are considering as a 6.67 into 10 raised to negative 11. What is M1? M1 is a Ram's mass, so it is 100 kg. What is M2? M2 is a Rahim's mass, that is also 100 kg, divided by distance square. Distance is 1 meter, so 1 into 1, that remains as a 1. See, 6.7 as it is. 10 raised to negative 11, 100 into 100, 10,000, and 10,000 is 10 raised to 4. So our final answer is 6.67 into 10 raised to negative 11 into 10 raised to 4. So as you learn in mathematics, if there is a multiplication of indices and if base is the same, then there is an addition of indices, means negative 11 plus 4, and negative 11 plus 4, that is equal to negative 7. So finally we are reaching 6.67 into 10 raised to negative 7 Newton. This force is very little force, but as we are comparing this equation with this example with the second, now anyone Ram or Rahim, because both having the same mass, are standing, he is standing on the earth. So this, the lower circle indicates earth and the upper circle indicates Ram or Rahim of 100 kg each. Then what is the force exerted by the earth on Ram or Rahim? See, mass of earth is 6.6 into 10 raised to 24 kilogram. Radius of earth is 6.4 into 10 raised to 6 meter. So M is the mass of earth and small m indicating for mass of Ram or Rahim, both having 100 kg, and R is radius. See here, as compared to the center of mass of Ram, the radius of it is so huge. So distance in between the person and the earth center is considered as the radius of earth only. So R's value is 6.4 into 10 raised to 6 meter. Now start to solve this one. G, 6.67 into 10 raised to negative 11. Mass of earth 6 into 10 raised to 24, and mass of Ram, that is 100. Then R square, radius 6.4 into 10 raised to 6 whole square. Now see for the indices. See what is indices? 10 raised to 11, negative 11. Here we have carried 10 raised to negative 10 raised to 24, 10 raised to 24, and 100 we have written like this one, 10 square. And here square, sixth power of 10 raised to 6 power raised to 2. That means here 6 into 2, 12. So total indices are negative 11 plus 24 plus 2. Negative 11 plus 24, we are getting 13. 13 plus 2, we are getting 15 here. And 6 to the 12. So finally we have reached here 10 raised to 15 divided by 10 raised to 12. And when there is a division, we have to subtract. Multiplication, we have to add. Division, we have to subtract. So 15 minus 12, that is equal to 3. So finally we are reaching here 6.67 into 6, 10 raised to 15, 4. Here square of 6.4 is 40.96 into 10 raised to 12. So finally here we are reaching here 10 raised to 3. Now we are going to do the multiplication of these two terms, and the multiplication of two terms is 40.02 into 10 raised to 3 and divided by 40.96, and this division we are reaching here 0.977038 and so on recurring. So finally 10 raised to 3 means here 977 Newton. So see, Earth is exerting pressure 9, that is force 977 Newton on Ram and Rahim. And see here, suppose this one is a Earth, this person is a Ram, this person is a Rahim. Ram and Rahim having very negligible force, and the force in between them is 6.67 into 10 raised to negative 7 Newton. But the force exerted by the Earth on Ram and Rahim is 977 Newton, and because of this huge force exerted by the Earth on Ram and Rahim is same, because of same mass, the Ram and Rahim will not be attracted towards each other, because the greater force Earth is holding to Ram and Rahim. Just we have discussed, because of the less force in between Ram and Rahim as compared to Earth, Earth's effect is more and Ram and Rahim's effect is more. But one more problem we have to discuss. If apple is falling towards the Earth, though the force exerted by the Earth on apple and apple on the Earth is same, why Earth will not be attracted upward towards the apple? Why apple has to fall on the Earth? Discuss here. See, suppose the X force is there, or X Newton force is there in between Earth and apple, but effect is different. See, this one is a chalk. The mass of chalk is very small. I am exerting the force on this one. If I will exert the force, see, there is a lot movement. But when I will take or hold this holder, mass increases, and if same force I will give here, that effect is different, because chalk has travelled a long distance, duster has travelled the little distance, but the same force I will exert on the blackboard, blackboard will not move. Why? Because effect of forces depend on mass. So what is the relation? Less the mass, greater the force, greater the mass, less the effect we are getting. Means object having mass more, then less effect we are getting. Suppose we are kicking to the football, it will travel a long distance or not. But if we kick the stone, it will not travel. Why? Because mass of stone is greater, so effect is less. So if same force is in between the Earth and the apple, who having the less mass? Apple having the less mass than the Earth. Earth mass is huge one, that is 6 into 10 raised to 24 kilogram. And what is the apples? It may be 1 kg. So as compared to Earth mass, apple's mass is so negligible or so small, so effect will be more on apple than the Earth, and so we are observing apple get attracted towards the Earth, Earth will not attracted towards apple. Thank you.